So on we go. Right, before everyone falls asleep here, so just wrap up. I just want to run you through basically writing an initial Docker file, just to have a brief understanding intuitively. Yeah. So the things we did up to now was basically looking for Docker images, pulling Docker images and running them. There are further options which are briefly explored, and we continue that as well, is such as mapping ports, right? I hope everyone got the understanding of what mapping ports is about. It's literally, don't kill yourself. Sure. It's literally about identifying which port, right? Which port, for example, port 80 or 8080 is bound to which port in the Docker container, right? So you could have multiple containers, now using weights. And you, for example, have a container that listens on port 80 because Apache by default or any web server listens on port 80, right? And now you have a second container, perhaps even using the same kind of configuration, also listening on port 80. And then you would be able to map it from port 8081, let's say, to port 80, right? So because you would run them all on the same host, but you can only identify, you need to identify them uniquely, the ports need to be identified uniquely on host level, and then you need to point them to the corresponding Docker container. So that's what the -p is for here. We'll explore that more, and you will need to use that more later on. Then we have the mapping of environment variables. We'll play with this as well. So, for example, you may want to inject an environment variable into your Docker container that you want to use for whatever reasons. Perhaps your code depends on it. And the idea of volumes, which is something we look at later, not now. Volumes is basically about attaching data storage to running containers. Yeah, because by default, if you run a container and you bring it down, it is not stateful in a sense, ephemeral. It basically doesn't keep track of the state that you injected. So if you have log files and you want to keep track of those, you actually need to redirect them into a container or a volume or a local file system. Otherwise, they will be gone with the container when it's shut down. Yeah. So, but we get to that again in a bit. So. All right, so what are the ways to create actually images? One of them is really to do it interactively. We did this. Basically use a base image, do some stuff to it, then commit the changes, and it becomes a new image. You can use it, right? But this, again, has this golden image effect, right? So suddenly we have this holy image that nobody can touch because you don't really know what happened there. The correct way, and the only way we accept it here in this course anyway, is to actually write Docker files, natively Docker files. So you do the whole build process from scratch. Yeah. So similarly as we do in Go, right? In Go also, you're not just giving us the binaries, you're actually giving us your code, right? Cool. So so how do Docker files look like? And they're actually a bit complex. I just dumped some aspects in one slide. I tried to do it in one slide at you, and I will just discuss some of them before we actually put it into action for the particular example that we have been working on. So each Docker file basically has some base image it starts from, and that is generally the syntax for that one is having the instruction followed by the parameters. So in this case it would be a base image. Then you would specify a maintainer. So that's the person that actually the author of the image, so it's best practice. You can specify environment variables. You can run specific commands. You can copy and add files. That's generally related to copying files from your local file system into the container. For example, you want to set up a ready-made container that has a configuration that you know about already. You can you don't need to recreate that file inside the container image, but you just copy it from your local directory. Yeah? You can change the work directory in the image. You can link external volumes. We'll talk about this eventually later. And you can expose ports. You can actually, the image can specify which ports it wants to expose, right? For the web server, port 80, if it's running SSH in the image, port 22, and so on. You can define it there. And at the end, you have something like an entry point. So, or alternatively, a CMD command. So, yep.
Entry point for what?
Yeah. So the entry point is basically like your main method for an image. So once you have done everything, set up, copied your files, set up configuration parameters and so on, this is the command that should be executed to run it, right? Basically like your main method in your conventional code, if you like. And there's two ways of doing that. One of them is using the entry point that by default doesn't carry any parameters. So you just execute it blindly. In the case of command, you're actually defining default parameters or parameters for its execution. So you may, for example, provide an image that allows you to append options during the or arguments during the execution. So so the idea is there that you can actually do that at runtime, or if you prefer to encode this entirely in the image itself. But instead of looking at this way, let's actually hack around and get some image going, I guess. So we do use a subset of the feature set, obviously, but just to give you an outline of the complexity, I just wanted to bring that briefly up. Okay, how do we do it? Best practice is possibly to create actually a folder for that one. So in our case, we create a folder that we call, I just call it, well, Docker Apache, but that's just made up by me. It doesn't matter. The idea is just that we have a folder that we can work off without any impact of other files and so on. So this folder will now be the build context. So if you have a Docker file, the folder that is contained is considered the build context. Meaning, for example, if you want to add or add files to your actual image during compile time, this is the directory it will be looking in, the build context. And inside this one, we need to now create a Docker file. So I use nano here for simplicity reasons and copy pastability in case I need it. And by convention, a Docker file is simply called dockerfile with a capital D. So get into file, empty file. So far, so good. So right. So so the first thing that we need to have is a from statement. So we need to indicate, okay, what image do we want to build from? Right. What we previously did would be something like this. So we have an image, a base image that we want to use, and a tag. And the tag here is latest. Is that a good idea or not? Why not?
Because the latest changes.
So Docker is really about building reliable solutions like infrastructure, right? So we actually want to deploy infrastructure, and that it has bloody just to run, right? We don't want to have magic there, but once we compile this, we want this thing to be reliable and run. So wherever possible, and especially in production, you would not just say latest tag. You would actually be very concrete about which image you're interested in. For example, the tag 1704, which would be the somewhat latest Ubuntu right now, but in fact, from a practice point of view, would use 1604 because you guys,
Yeah, every even number is LTS, and that's supported for 5 years.
There you go, right? Because you guys know that the LTS versions are the ones that are supported for longer terms. Exactly. So for this thing, you wouldn't use a 1704 unless you want to try reasonably recent features, but you would actually go for the latest LTS. Yep. So which is 1604.
And that's promised support for 5 years.
Yep.
Right, with
Exactly.
until 2021.
That's right. Cool. Yep. So we use 1604 because that's the way to go, the correct way to deal with 1604. So cool. So we have a base image. What else do we want to do? So we have an empty base image, which we kind of like. What was my next step? Label, maintainer. Hang on, let's get the syntax straight. This email is someone at cloud.com, right? Cool, not this one, this one. So we have a label. The next thing is, remember, we want to install stuff. We wanted to install Apache, and that was of moderate success. But first of all, we actually need to update the packages we have in the image. So what I previously did, what was the command I ran to do that? To update the repository?
Get update.
Cool. So that's that one. What did I do afterwards?
Install Apache.
So I did something like that, right? Apt-get, what is it, install. So now it's about dealing with interactivity. When you, what happens if you run apt-get install? Do you recall what happens? Yep.
Dash right to accept all the prompts.
Yep. So any command that's interactive, you kind of need to ensure that it's scriptable, right? So many commands in Linux are either made for dialogue interaction, or for interactive use, or for scripting use. An example, any example for that apart from apt-get install? Sorry? Right, yes, yep. So those persistently running ones, yep. So, or top in general, yep, it's the same thing. But for example, in Linux, you have two different ways of creating a user. Does anyone recall? No? It's user add and add user. User add is the scriptable one. So one long command line, including all the parameters, and it will just create the user, no feedback, or bad feedback if things go sideways, or add user, which asks you like 5 different questions, and actually you need to answer them. That's not scriptable, right? So in this case, we want to have the same here. We want to override any possible prompt. All right, cool. What do I want to do? Yeah, Apache 2 was the package name, and we also Apache 2 utils. Cool. Next thing. We want to expose a port, right? There was port 80. From the image perspective, we want to expose port 80 because it's the default port. And finally, we're having a entry point. Sorry, entry point. So there's always space after the initial keyword. And then that was the command we want to execute, and it was user sbin apache 2 CTL, and we're having a set of default parameters that we want to pass along. One is the -d, and the other one is foreground. So every time you have a white space in between, they are treated as individual elements here in this set of commands in this array here, right? So it will basically combine. It will run the command user sbin apache 2 and append, by default, those two options, those two parameters there, right? So you could override them as well if you wanted to, right? Yep.
Is it really the entry point, or is the run stuff?
You mean this one here?
Is that done before the entry point?
Yep. We get to that. Yes, exactly. That's right. So every time you run, the system generally expects a change of the underlying image. So some state modification, that something happens, right? May not always be the case, but if it's the case, it creates a new layer of the image. It creates a new layer of the image. So first we have the base image, then we run the first command that leads to an additional layer of the image. Then we run the second command, new layer of the image, and then finally, given that ready-made image, we're exposing the port 80 and using this as an entry point. Yeah, so that's the difference with run. So run does not define a procedure entry point of the image, the runnable container, but it just says what should be done to create the image. Yeah, so it's only doing compile time. This is runtime stuff here, down here. Cool. So there's also one best practice about this kind of stuff. Since I'm not sure if it's fixed in really nowadays version, but the idea is that run apt-get update leads to an update of the package catalog, which may or may not lead to a change of the underlying data files or data structure, because there may simply not be an update available. So in which case, the command would be simply ignored by Docker, or the effects of the command would be ignored, which can sometimes lead to problems. So it has become best practice to chain those commands. So under the condition that the updating of your catalog is successful, run the following command. That's the logical connectivity of end in bash is, if that is successful, do the following. Right, so it's basically chaining those commands together. So run apt-get update and run apt-get install afterwards, and so on. Yeah, amazing.
If you expose on multiple instances the same port,
yeah,
what would happen?
Yeah, what would happen? Anyone? he asked if we have multiple instances, right? So of Docker images, right? Or containers. So containers being the images, the instances, sorry. And they expose the same port. What would happen? Yep.
Two element changes because they are independent.
Yeah.
And this is only the port from the Docker perspective.
Yeah.
And we have to call some release or about this mapping ports like 8080, 8081, 8082,
That's right.
and so on.
That's right.
From the outside.
That's right. Yeah.
Because all the other are, if you have the same web servers that you expect that they will react the same way. So if you are asking the web server on port 80, so this redirection to the Docker goes in this host layer.
Yeah. Okay. Yeah. Cool.
Then every instance will get this 80.
That's right. So the answer lies there. So you need to specify the mapping between host port and container port as part of a Docker command when you run it. I'll show it to you again. So first of all, I get out of here and then I bring up the command again because it's still in my cache. So this is should be the fully fledged Docker file right now. So we just saved the changes. And here, you saw the mapping here. There you go. So the container internally is an Apache container. It runs and listens on port 80. Note, previously I wasn't explicit about it. Just installed Apache and it kind of knew that it listens on port 80, or I kind of knew. But now the expose parameter was very explicit, right? So the system knows that it's supposed to listen on port 80. What we said here, take the host port 88 and redirect any request that's coming to that port to the container port 80. That makes sense? Yeah. So if you have a second image that we want to run, or a second container, we could say redirect port 8081 to port 80 on that new container. So there would be no conflict between the different ports on container level. Only on host level. You need to kind of manage it, right?
Yeah.
Cool. So let's get into building. All right. So Docker, and that's the build command. I tend to tag builds immediately, otherwise you have like cryptic unique identifiers that are hardly helpful. So Apache build, I'll just make it long. Yeah, cool. And I'll just do that, so it will look in the current directory, look for a Docker file and try to build whatever it's doing. So this will be the first bit of it, so we walk into that in a second. See if it fails. So it's basically doing everything in the foreground apart from things that failed, so we get rid of that in a second. So let's retrace what actually happened here. Yeah, it failed already. Good. I like that. So all right, it's sending the build context to a Docker daemon. Basically, it's everything in that file environment. There's nothing there apart from Docker files, so no magic. First step, it's getting the instruction from Ubuntu 16.04. So what's doing is basically pulling the Ubuntu 16.4 tag, meaning that image there, right? So we have a consistent version. Cool. And as a second step, it's introducing the label maintainer. So note how it's actually layering this up in the image. So it changes the image and now has the maintainer as part of it. And then it's running this long stretch command here, run apt-get update, which seemingly seems to work. But when running, we actually found, oh, Apache 2 utils doesn't seem to be available. So we probably get rid of this. And Docker identifies that based on the response code that it gets from the command. If it's a non-zero response code, it usually implies that something went sideways. It's a convention, for scripting anyway. So what we'll do now is go back into our Docker file, fix that, respectively remove that, and try it again. Again, it does the update. This enforces the update, basically. And now it's actually doing what we want. Again, Apache takes a while to install. So, yeah. Cool. See how successful that will be, and then we can see if we can instantiate this. Yep.
How do you do load balancing? Because you talked about this mapping, but
yeah.
I don't understand how if you get like 1,000 requests from
That's right.
the port 80.
You asked this question before. Basically, that's right. This is an infrastructure problem. Right now, we are not at that level. Right now, we're just looking, okay, how do we develop individual, for example, microservices that are really dedicated? The advantage of Docker here, which we didn't talk about, where we can, while it actually is doing that stuff, that you can structure your applications in a more refined manner. If you think, for example, about your assignment 2, you basically have one massive service that does everything, right? But you could actually look at the service and decompose it into, for example, database, the most obvious one, and other elements such as the main service that does the web invocation, and other sub-services that you can think of that do the inquiry of the fixer API and so on, right? If you have those individual components and compose them into individual Docker containers, you can scale up one or the other, right? So for example, you have more load on the web service side of things. You can scale up only that side instead of scaling up the entire service on a whole, right? So Docker gives you the opportunity to actually separate those different elements of your program. What it doesn't do out of the box is dealing with the scalability itself. That's another infrastructure we probably won't be covering in depth, but it's called Kubernetes or Docker Swarm that does that. That actually looks at requests and then scales up your instances. But Docker itself just provides you the infrastructure to have those components or containers.
Yeah,
yep.
That was not actually what I was asking. I was asking about like routing to the different instances. So you have a host machine,
yep.
And the host machine has the actual port 80.
Yep.
And the actual port 80 gets 1,000 requests.
Yep.
How is that distributed to different
instances? That wouldn't happen. Again, that's a different discussion. Right now, the host machine that's running a Docker container actually doesn't get 1,000 requests on port 80. Most likely it will get requests on 8080, 8081, 8082, 8083, right? All the different, so that are linked against additional containers. However, who gets that load is the load balancer sitting in front of your Docker instance. This guy gets all requests on port 80 and then needs to decide how we distribute this over different containers. So what I'm saying is the infrastructure doing that one comes before or on a higher level than the Docker containers. Right now, we're just looking at the mechanisms of how could we possibly structure applications and actually, make them scalable in the first place. The mechanics, yeah. So it's a fairly complex topic. That's basically a cloud course on its own, but we'll cover that later once we at least understand how the container principle works. Yeah. So just to come back to our discussion or our image building, so that finally worked actually out. After installing Apache, we exposed the port, that's worked. The entry points have been defined, and we successfully built a new container, and that has been tagged Ubuntu Apache build latest. So since I didn't provide an explicit tag, it's tagged it latest, which is the default tag. So if we now look into sudo docker images, it may eventually come up with this one. So we have a latest build here. That includes everything, and without much surprise, there's the same size as the previous build that we did by interactive coding. But the advantage now is really that our whole build process is now inherently transparent. So there's no magic image, no golden image anymore, because everyone who has that Docker file can rebuild all images on their own, right? That's why important to have those files as part of your deliverable. And to instantiate it, see if it actually runs. That's usually the interesting bit. Run-d, we need to map, we give it a name, Apache builds, for example, we're mapping ports. I'm not sure if the origin is still running, we just see if it breaks. We're mapping port 8080 in the host machine to port 80, and we called that thing Ubuntu Apache builds latest. And see if it actually does. So 8080 is already allocated, meaning the other server is still running, so we use port 8080 81. Right now, yes. So I already instantiated an image with a given name. So finally we got it going. So the reason why it didn't run before was basically all 8080 was bound by our original self-built Apache container. But now we have the new image running. So now it's basically available and can be accessed and invoked. But now it's fully, basically self-contained this way. By the way, once you specified extending on the complexity of setting up or instantiating an image with all those parameters, once you did this once, you can just stop and start the container based on its name, right? You could say sudo docker stop Apache build 2 because that was the name I gave this particular container. And it will eventually come down. And then you can just run sudo docker start without any of those additional parameters. They will be they're still kept as part of the configuration. So it makes it quite straightforward. So you don't need to rethink the port binding every time you're starting a container. Yeah. So that's the key idea there. So that's the idea. Right. So one thing we can probably append to it. So right now we have a self-contained image that sits on the Docker instance. Perhaps one thing I wanted to highlight is the use of volumes briefly to some extent, because the Docker containers themselves, again, they're not changeable at runtime, right? So anything that happens to them, invocations, they're not persistent. The log files will be deleted or will actually not be stored in the first place if you bring down the container. So the only way of inspecting it is either by binding it foreground, as we did before, so you get the output directly, or by linking file locations or file system paths in the image to your local file system. And for this purpose, we can use the idea of what's called volumes, Docker volumes. And to do that, we firstly obviously need to create some sort of location on the file system we want to use. For the sake of simplicity, I will create a folder called dash data. And what I want to put in there is a let's put in a web page basically, because recall that the Apache server delivers a default web page which is fairly straightforward and it sits in a particular location on the image. So now we want to create our own one. And hang on, I think I still have from our last session, I still have a remnant of a HTML file, which you can just copy in, so we don't have much fuss with this. So we get some title and we get some, magic on Docker thing. So it's basically a simple HTML we can use. Damn, my bad. I didn't start Nano with sudo permissions, so I need to do it again. Cool. Right. So that works. So now we have the index file bound to the data directory. So. So how do we bind them to the container? First of all, we will need to create a new container instance. So we just reuse whatever we have, but we name it Apache build volume, let's say. So we actually have a volume attached, and we have ports binding to port 82, for example, 8082, because the other ones are still bound. We have now at least 2 containers running already anyway. And you notice here they are. So this is our original instance that is bound to port 8080, 8081, the recent one. So now we want to bind a volume. And what it basically does, it shadows or basically hides a server-side location in the file system. And we do that with the v command. First, we point to the local data directory, and then separate it by colon, and indicate which location on the container image it should hide. Basically, it will overwrite any content in there. So instead of, whenever this container now attempts to access the location var w HTML, it will actually end up on our local file system in /data. That's the key idea. And if I got that right and have the permission properly set, then it may actually work. So let's see. Just do a, that's port 8082, so I do a wget on localhost port 8082 We got permission denied, so that's probably not gonna happen. So let's see, ls-lr, which is fine. I get permission denied because I can't write to the data directory. Cool, hang on. cd come on, tilde, where are you? There you go. Sweet. So again, wget localhost 8082. Cool. So if we look at the index file now, it's index.1 because I did the previous download. We see exactly that. So we basically replace the content, and it's now dynamically mapped against this directory. So if we, for example, go back to /data and we actually say sudo nano index HTML and we do some whatever. We will now see if we do a download again, that it actually, I'm always in the wrong directory, it's not going to happen, so cat index image 2, that now the content points to some whatever, right? So it now binds to your local file system, so we actually have a way of linking your container, the execution of your container, to state on your host, right? In this case, we had the /data directory on the host, we can modify it, and is linked to the corresponding directory on the server that holds all the websites, right, for example. So this way, we isolate the execution bit of the web service into the container and deal with the actual state locally or in another volume. So it could also be a dedicated non-executable container which just stores data. It's called a volume in this context, but that's the idea, so we can separate containers. It also implies that multiple containers could use the same directory on your local host machine, right? So you could serve the same website on different containers. Okay? So that's the key idea with about volumes that we have here. Cool. Right. So, is there anything else I'm eager to share with you apart from this? No. So next session, we want to actually go about like Dockerizing a Go application, which is a tad more involved, and looking at some best practices for writing Docker files by looking at other Docker files, because we only exploited you know, a subset of the functionality right now. We only looked at the from statement. We specified a maintainer. We didn't look at environment variables. We did some running of commands like apt-get and apt-get install. We didn't really copy local files, and we didn't really work with any of those commands other than exposing and defining an entry point for execution, right? But this was basically the idea of running a or specifying an image for Apache 2. So that's the idea. So what I would really like you to do is to get comfortable with this, at least install Docker on the OpenStack, in the OpenStack environment or locally if you can, and just start playing around with this. Perhaps first even by downloading images, just running them. Note that many images actually need, for their containers, need particular parameters. They're usually part of the image description. They provide them quite explicitly. Yeah? So you need to run those ones, but then move on from there and actually write your own Docker file. You know, it can be a simple hello world thing, just to get comfortable with the idea of having a directory which is your build context, adding a Docker file, which are all the necessary instructions, and just run Docker build on it and see what happens. Yeah? And then try to run it afterwards. Cool. Any questions for now? Who's totally lost and doesn't know what we're doing? Who thinks, yeah, that's not something I should be dealing with because I'm an application developer? Well, just as an illumination, that is probably going to be the de facto standard for delivering applications in the future, right? So right now we have a lot of, you know, we moved from providing source files to having build environments, you know, build tools like Maven, Leiningen, and so on for different programming languages, Gradle, and so on, to automatically build your application. We're moving further down the track that it's actually really about going to the end level of deployment. So someone who deploys applications, if he or she is provided with your Docker file, they will just be able to run your Docker file. You did all the operating system level specifications that are necessary, and it will just run, you know. And instead of getting your, you know, perhaps not optimally structured web application in, you know, with one tool chain that actually runs, but it's actually not thought through in terms of scalability, because here you need to also start changing your mindset and think, okay, since it's running in different containers, and some of them may be replicated or not, how do I structure my application accordingly now? Because it basically feeds back into your development thinking and structure of that cycle. But I'm nearly going as far as to say I'm betting that this will be the de facto standard for deliverables in the future. You basically deliver your source code plus Dockerfile, and then it just run with Docker build. Yeah. So that's why, yes, you need to learn that, I think. I mean, I would strongly encourage you. Plus, it's actually fairly easy. I mean, once we get more comfortable with this, and you have done it like 2 or 3 times, it's just a matter of looking up the commands you forgot, and that's basically it. We look at some best practices tomorrow to make it easier, but
I just want to point
yep.
out that I see you are linking free code camp there.
Yep.
Free code camp is like the easiest, like it's extremely simplified the learning experience.
Yep.
So you should probably check out the free code camp link.
Yep. So, but it's actually also worthwhile because the reason I'm linking this is because we're looking at it tomorrow and see where we can improve. So, yeah. But I took the image from there. That's why. It's only image reference. So, yeah. Okay. Thank you very much.